Hey there, and welcome to another how-to video. This video is a little different than most of the content I've been putting out. This is going to be a sort of guide through getting started with SolidWorks Electrical, the piece of software that I absolutely love, especially for the industrial applications. It does a lot more than that. I use it primarily for industrial ladder wiring diagrams and that sort of application, but it also is capable of wiring harnesses, sort of standard circuit schematics, all kinds of stuff. Um, so I guess we'll dive right in. When electrical launches, by the way, just for, sort of where we sit, um, I think this is a default installation. There are some tweaks and things that I like to make to sort of my formats and how it does things when I use SolidWorks Electrical. I don't honestly remember if I've done any of those on this installation. Because it's been so long. Like if you look, the creation date of this template on the screen here is, in April. It's now October, so that's the last time I've even touched it. So I think we're default. I hope we are, because I would also like to, maybe not so much in this video, because this video is really just how to get started and create something usable. Um, but maybe in the future go through what some of those tweaks are, get some of the things a little more, at least the way I like them, the way that sort of most of my customers in the past have, they prefer their things set up a certain way, stuff like that. So when you launch SolidWorks Electrical, you will end up with the project management window popping up sort of in the beginning. And this isn't a completely fresh install, I should say, a brand new installation. When it first opens, you will be faced with a window with a long loading bar, and that loading bar can take, I don't know, 5 minutes. Sometimes shorter, sometimes longer, just depends. That's SolidWorks loading all of the database stuff that it needs to make this software work. SolidWorks Electrical in the back end is entirely database driven. Cool part about that is there's only, as far as I can think of, only one time we ever have to hit save. As we're working, everything's automatically saved because it's modifying entries in a database, and they're done in sort of real time. There's an exception to that. We'll get there, maybe probably not in this video. That comes with more of the custom stuff. But so good news is we don't need to save. You do need to sit through that progress bar. Once it's done, then you'll be faced with the project management screen. I'm going to go ahead and create a new project. There are a bunch of templates that it loads automatically. You can also create your own. I have done that in the past just so that it loads the settings and templates and title blocks and things that I like. For now, though, I'm just going to stick with ANSI. I mean, I am in the US. I'm going to stick with an ANSI template. I will say that SolidWorks Electrical seems to be anyway. And again, I'm not intimate with the company. I don't have contacts. I've just been a user for a while. Seems to be heavily geared toward ISO and IEC specs. There are certain things that I can't, again, when we get deeper in other videos, there are things that I can't quite figure out how to, for instance, not make metric, um, stuff like that. So, but it's perfectly serviceable. It works well with ANSI, so we're going to do it with ANSI. So, we create a new project. These are sort of default database entries that we can enter for various things, and it will treat these later on like variables. We can pull this information in. For instance, a customer, we could create a title block with these as variables. So it'll pull this information into our title blocks automatically, that kind of thing. So helpful if you know it ahead of time to fill some of this stuff out. You don't have to, but it is helpful. So I'm gonna give it some titles. I mean, let's do I'm gonna call the project walkthrough. Let's call it walkthrough video one, just for the sake of giving it a name. Contract number, I usually treat that as the job name. It says number, it does not have to be a number. Again, it's going to treat it like a variable, which we can pull in later. Customer, why not? Let's give it a Baker College and give it an address. Then maybe if I decide to pull some of this information in, um, if I decide to pull some of this information in later into a title block, it'll be there and I can demonstrate where that, sort of comes from. Cadillac, Michigan. Let's see. Version's fine. Addition to that's system information stuff. I don't think we need to worry about any of that for now. A description is good. That's usually just a longer form of, say, the title or the SolidWorks. And again, you don't have to input any of this stuff. I'm doing it now just so that because I do these videos, hopefully, if you haven't noticed by now, completely unscripted. Like I have an idea in my head of where I want to go, but there is no script. Um, and maybe, when we get into creating drawings, I want to put some of this in the title block. So I just want some of it there. SolidWorks Electrical Walkthrough Video 1. That'll be a description we can see maybe. So it'll connect to the database, it'll build some stuff, pull some stuff in, and we have a project. We have a tree over here. So similar to SolidWorks now, I also want to get a misnomer out of the way. So SolidWorks as a company, or I should say Dassault Systems, the folks that own SolidWorks, and I probably butchered that pronunciation, but they are sort of well known for purchasing other companies who have created softwares that play nice with SolidWorks. As a for instance, SolidWorks Visualize is the new software that they use for rendering, creating photorealistic versions of your solid models. That was originally a third-party piece of software that played nice with SolidWorks that they bought and now badge as SolidWorks Visualize. SolidWorks Electrical started out the same way. It was a third-party piece of software, and not that long ago. I want to say it's only been SolidWorks Electrical for like 10 years, if that. Prior to that, it was a third-party software, and I forget what the name was, but it had a name. And then it played nice with SolidWorks. You could do your electrical schematics, and then it would actually export SolidWorks models of, say, your electrical cabinet with all the components in place. SolidWorks liked that. They bought it, badged it under their brand, and here we are today. So some of the things, all that to say, it's best to think of this as a completely separate entity from SolidWorks because a lot of the workflows and a lot of the even commands that we're used to do not work the same way here as they do in SolidWorks. So just a thing that I wanted to get out there to sort of keep in mind. But over here on the left, we're faced with a document tree like a lot of softwares like SolidWorks. Everything in electrical is based around pages. Each one of these, if I open them up, we've got a cover page, right? And it automatically, like I said, pulled in the title of this project that I gave it, walkthrough video 1. And if I zoom in, this title block template, the default has got the contract, as a variable already pulled in, and the customer, Baker College, I put in the customer field, right? So it's got some of that stuff on a cover page. We've got a list of drawings. Right now, this list of drawings is only populated with the default ones that come in, and these 5 drawings are by default the ones we get to start. By the way, as I'm opening it, notice along the top they stay open in tabs. So if I open the line diagram, I'll get a third tab, line diagram. Again, this title block pulled in. Well, actually, that's just the title of this page, main electrical closet. If I right click here on the line diagram and go to properties, you will see that somewhere in here it is called main electrical closet. So that's where it pulls in, that variable name. So line diagram is a thing we may get into later. Line diagrams are very useful. They're very useful for a couple of very specific applications. Just about every drawing set that I create has at least one nowadays, but that's not primarily where we're going to live. This icon here next to power is the icon for what SolidWorks Electrical calls a scheme. And schemes are primarily where we want to live. A scheme is a wiring diagram. Okay. This is a standard wiring diagram. The line diagram is a different thing. And I'm going to go ahead and close the rest of the tabs so that we just live on the power scheme. And I typically leave at least this power scheme somewhat. I mean, I draw on it, right? I create a schematic on it, but I typically leave it somewhat as is, as far as leaving it called power. Maybe I might change it to like 480 volt power and do another one called 120 volt power. Depends on the layout, but it's a way. So each document is just a way to keep things straight. But we've got power. We also get control. So by default, they're basically giving us, we could just go here and jump in and start creating on these and be fine. So I am going to do that. But the one thing I am going to do first is I'm going to change this title block. And again, I have in the past created my own. I haven't done that on this installation. Um, but I am going to go to title block. I can right click title block. I'm going to replace it because what I want, first of all, I think I have changed this enough. I believe SolidWorks Electrical defaults to A size, and A size is the standard 8.5 by 11. Um, standard printer paper. I prefer to work on B. We don't do a whole bunch on D anymore nowadays. D kind of requires a plotter, one of the large printers. B, though, is 11 by 17. Most of the printers, the big guys that you rent in like office spaces or factories or manufacturing facilities, all that good stuff, are capable of 11 by 17. It's also cool because while it's not exactly a multiple of 8.5 by 11, if we draw on 11 by 17 and we scale it down to print on 8.5 by 11, things tend to still be readable. Like if it looks good, we lay it out well on 11 by 17, it'll still look good if we scale it down to not quite half the size, but you get the idea. So I like to work on B. Um, with it gives a little more real estate. We can get a little more on there, and our printers can usually handle it. We can usually print out a B size sheet. But what I was actually in here so that's that. It might default to A. I recommend sticking with B for everything. What I really wanted to do while I was in here, the reason I came in here was I want to change to this B with two columns. And I'm going to select that. And I'm going to go ahead and do identical in current project. So what it's asking, when you change a title block, it's asking, do you want to change it to just the drawing? Like I selected the power drawing. Do I want to change just that drawing? Or do I want to change the title block in every drawing that uses every scheme, basically, right? Everything that used that original title block. Um, I really, at this point, want to do it to all of them. So I'm going to do all drawings, update, yes. So what this does now is it has split it into two columns. It has automatically giving me the page and line reference. So page 4, line number 1. That's automatic. Um, it's in two columns. So when I draw, I'm going to do a quick demo, way out of order. I wasn't going to do wires yet, but I'm just going to throw a wire in here. So this wire is in column 1, and I'm going to throw a wire over here in column 2, right? And now to number these guys, that is actually up on the toolbar under project, actually process, sorry. Number new wires. Yes, I want to modify or number new wires. Okay, and that didn't work with that particular wire. This is maybe one of the things I need to jump into first. So let's go back to schematic. Again, unscripted. You got to love it, right? So maybe I have the wrong wire style. So there are multiple wire styles available to us. And we can do different things with those. So if I click here, I had by default 12 volt DC selected. That's this guy. What if I do 24 volt DC? So one of the things I do like to do, because I'm not nuts about really any of these, frankly, any of these that come in. One thing you'll notice, let me switch to this, the N1, the three phase, right? Notice the colors. When I come in here, first of all these are checked because that wire style has 5 wires with it. So when I select that one by default, because they're all checked over here under available wires, when I click, and I'm not dragging, by the way, to draw wires, you don't drag, just click to start it and then move your mouse. And then a second click ends it. And I can make a turn if I want, or I can right click and be done. So let's see now what it does if I do process number new wires. Yes, number them. It just gives, okay. So we automatically get a neutral N1, L1, 1, right? Leg 1, leg 2, leg 3. But I'm curious as to why when I drew a wire, I should get, the reason I do this is I should automatically get a wire number that is of the format column or page and, number, page and row, I should say, page and row. So I want to see why that didn't work. Number new wires. Yes. All right. So we're gonna actually modify. I was gonna save this for another video, but I want to modify basically how it numbers things. And there are a couple of ways to do that. And I got to be honest, it has been a minute since I have been in here. So bear with me while I find the actual settings. Not in Cable Reference Manager. Is it in Project? I believe Project Configurations. And let's try first wire style. Is this the one I want? And let's go 12 volt control. Select it, and it opens up a bunch of settings. Here. Here is where we're looking. So this is the wire style. The line color is light green. Um, Actually, that was 12 volts. I want 24 volt. We're living in a 24 volt. I mean, industrial controls, we're in a 24 volt world, right? Typically, what I prefer for 24 volt control, I like to set my line color, edit that line color, because the line color, when we export this, when we print it in color or we export it to a PDF, which is also common, the line color set here is what is actually going to print. And since 24 volt DC in the US, according to NFPA 79, is blue, I like to set it to blue, a blue line, right? It's already a continuous line. Zero width just means it will print. It's just the thinnest line it can be, which is fine. Also down here, white. So this is different. General, the line color here is the line that'll show up on our drawings and when we print it and when we do PDFs. The wire color here is a physical thing. We can add that as a label later, basically pointing to the wire saying, hey, this is a green wire. Hey, this is a blue wire. I also like to set that appropriately. So I'm also going to set that to blue. Notice we can do, like if I was doing the neutral, and I will do that in a mirror neutral, the DC common, and I'll do that in a minute. I could do for DC common white and color two is blue. Right? It's now a white with blue wire. And when I can actually demo this. So I've changed it. I don't have to save anything, right? I mentioned everything's updated in a database. It is now blue over here. Everything's good. I'm going to close. I'm going to draw that wire. Schematic, draw a single wire. Make sure I got the right. I didn't have the right type selected. That's still on 12. I want the 24 volt that I just edited. Oh, and actually I changed the wrong one. I changed AC. So let's go back. Let's do things right. I changed the wrong one. 24 volt control. 24 volt. It was in the description. I just saw the control. So let's change that. I don't use the AC one much, so I'm just going to leave it alone, even though it's wrong now as far as color code is concerned. But I'm going to make this blue as well. I'm going to make the actual physical color blue. Okay. Okay. Close. Now let's draw that one, right? Now that I've got the right wire in there, let's go ahead and draw using, that's AC, using the right one, 24 volt. Okay. I'm going to draw this wire. Now there are two different types of labeling on a wire, two different types, and there is an actual difference between the two. There is, and one of them I can't actually show you. Well, now that I think about it, I don't think I can show you the physical wire call out that SolidWorks automatically generates. It's where it tells us, yeah, this is a blue wire, and it also gives us the wire gauge, which is handy. But it needs to be connected, so we'll get there. But I now have a blue wire. Let's end the modification there. I got a blue wire, right? I can also in my electrical project, while I'm on the topic of creating and modifying wires, in group one, I can add a new wire, and I am going to do that. It's now called control. I'm going to open it up. Its name is F30. I don't think I want it to be named F34. Name, what they named it here. 12 volt. I'm going to name this double click in the right spot, buddy. We're going to call this DC com, right? DC common, and that's going to be my white with a blue stripe. Now, actually, magenta, I'm okay with because again, this line color is how it's going to print it. That means every time I use this wire as a DC common or negative, it'll print as magenta. But later on, when I do the physical call out, I can, and I'm going to call it a white with blue. White, blue. Okay. We can also give it a gauge. I recommend doing that. The problem is right now, I don't know what that is. I don't know what gauge we need. And to be frank, it's a pain to change later. So we're probably best off right now if we give it a gauge. I'm trying to think what a good gauge. Let's call it a 20 gauge, 20 gauge, 18 gauge. Let's call it an 18 AWG. Um, Wire size standard. This realistically is only a database tag, that field. So AWG, this is what will print out when I get that far. Um, the wire size standard here is strictly where in the database it's going to live. Like if I need to go look it up, even in my wire manager, wire style management, the window you see sort of in the back here still, it'll be under all the wires in this standard. So that's good. Voltage, frequency, description. Let's call it a 24 VDC common wire. I like to be complete just to give it a, and it's what, 18 gauge. I like to be complete as I can just for me. So now the labeling thing, the reason that SolidWorks labeled it as wire number one has to do right here with equipotential and wire formulas. These are two different things. Um, and the best way to sort of explain the difference equipotential um, is the wire different from another wire? So if I run two wires, say, into a terminal block that has jumpers, electrically they are the same. Therefore, the equipotential will be the same. That is not necessarily the same as a wire number. Now, frankly, I don't get deep enough into the weeds in SolidWorks Electrical to care about the difference. So I set them so that they are numbered the same. They use the same formula to calculate what the numbers are. That way, no matter which one I grab, my schematic ends up with the same number. You know what I'm saying? So the problem is right now, this field is the formula. Notice the little FX over here. That's actually a formula. Equipotential order number and wire order number, those are variables. SolidWorks Electrical is looking at the drawing we have in front of us, in this case, the power drawing, looking at the wire we drew and saying, is it the first one or the second one on the page? And it's giving it that number, just one, two, three. So if I OK out of this and drop a couple of wires on there, make sure I'm on my, the cool part is it saves 24. Once you use it once, it'll be on whatever you used last. Now you also have to pay attention that that's the wire you want to be on. So I'm just going to drop two wires in here and number them. Process number. Yes. All right. 1, 2, different wires, order number. This one was drawn first. This one was drawn second. You need to be very, very careful. So if I go to schematic and add my wire in, we very rarely, by the way, want to be on the draw tab. Draw tab, very rarely. Where most of our stuff is on schematic. We want to live on schematic. But if I draw a wire above that, okay, and then I hit, let's go to my process and number new wires. Yes, it's only going to number that one, and it's going to give it a 3 because that was the third one I drew, right? 1 and 2 were already taken. What we need to be careful about when we're adding wires is the renumber. Renumber, and I'm going to leave everything. So number new wires or recalculate existing marks is what comes up by default. Okay, the whole project, and hit OK. It should. Oh no, it didn't because of the order I drew them in. I was going to say it should reorder these 1, 2, 3, but because of the order, it's still stuck with the order I drew them in. But I'm All right, I'm going to leave those in there because I don't need to keep redrawing wires. I do want to go to my project and my configurations and my wire style, and I want to change how. So the standard format that in the US anyway, most companies, most customers are going to look for is we want to see page number and line number as the wire number. We don't want to see wire three, right? We got 400 wires in this thing. I want to see page number, line number. That way, if I've got a schematic book in my hand and I'm staring at an electrical panel, I can match up wires, find them on the schematic. Everything's cleaner that way, right? I'm guessing, like, I don't know where wire three is on the page. So I want these to be numbered, page number, wire number, right? Page number, line number, I should say. And that is in that configuration, in that formula. So let's go back to my, sure I'm on the right one, 24 volt. That was the DC, right? Yep, 24 volt DC. Okay. Let's, I'm going to move that while I'm in here anyway to gauge AWG. Um, and I don't know what this diameter is as far as wire gauge goes. Small, like 40,000 sets a millimeter. It's small. I don't know what gauge that is, but anyway, again, equipotential order number, wire order. So that's the formula. That's all it's using. What order was it on the page? Right? I'm going to edit both of these formulas and make a match. So there are some defaults in here, right? We have equipotential order number, like counter. What order did I draw them? The counter on three characters. So if I change it to this one, let's just say I want to change it to this one. Double click down here is now showing me this is the formula it's set to. It's also in bold now, right? Right, okay. This formula on this page has updated, right? So now, okay, close. I'm going to renumber these guys. Again, default, number new, recalculate. Recalculates the key for this step. You need to be careful when the schematics are finished about recalculating because you could really screw something up, right? Once you actually have a physical thing sitting on the ground, a physical panel, physical machine, you do not ever want to renumber. You only want to number new because then it won't touch the existing. It can really, really screw up your existing versus your physical thing. So, but what that did is it's now in three characters, so it has leading zeros. If I draw, let's draw a whole bunch of them. Right, let's get up to 10 just to show that the leading zeros go away because that formula now is basically calculating like whatever the wire number is, make it take up three spaces. And that's a trick we're going to use because we're going to use that same sort of trick when I actually get my formula in there because I like it to always have four spaces. And I should be able to, let's see. Oh, I was trying to count lines, but I've already got line numbers, so that's just that should be 10, right? So now if I process, renumber, and let it do its thing, I should get 0, 1, 0, right? Just one leading zero. So it'll always be three digits. That's the formula we selected. So again, back to project configurations and the wire style. What I want, I don't believe is actually a default. And to be frank, I usually Google the formula that I actually want. And again, I'm going to make those two match. Right now, I'm just sort of talking through. We got two here that don't really work. I'm going to try to build a formula with you all sort of live via stream. You can, by the way, click. These are simple formulas. You can click these and it brings it in. And actually, some of that is actually what we want. I want some of these. So we're going to go to predefined. And can I make a new one? I think if I remember right, this is one of those things you do once when you install SolidWorks Electrical and you never touch it again, right? Because it's done. It's remembered forever. So it's one of those things you do, once every other year when you end up with a new laptop and a fresh install. Or if you're smart, like I haven't been in the past, you can actually export all of these settings and import it into the new install. I'm just not that smart. Um, we can do that. So these are like on this tab, variables. So you don't even have to remember what they are. You don't have to Google what they are. And it tells you. So again, equipotential order number, equipotential counter. I don't really care. I really don't care about the equipotential counter. What I care about is I want the page. So I'm going to look for file. That's what they call each one of these diagrams is a file, right? I want the file order number, right? Drawing four is what I want. That's the order. It's the fourth drawing in the book. So file order number, then a plus sign, and then somewhere on here should be a line. Equipotential, location, file, folder, book, position, maybe? Ah, row, right there. Row order number. Now, I don't want just the row number. I also want the row number in two characters. Like for row one, I want 01. They don't have that as an option that I can just select, but I can copy basically what they did here. This string Z, this whole formula here, forces the file number, the page number to be in two characters. So if we basically copy that, but instead of file order number, use row order number, we're going to get the row in two characters. So I'm going to do the string Z with its parentheses val. So it's telling it uh, everything in the string Z, strz, it's going to turn into a string. It's no longer numeric, which is important because you can't have leading zeros on a number. But it's going to do that to the value val of the row. I'm going to go two characters, and the leading, it's going to fill with 0. Okay, that's it. I'm going to hit enter. That's now my formula for equipotential. Now I need to do that and copy that to the wire as well. So I'm going to copy this whole thing. Notice it added current formula. I can also give it a name. I can give it sheet number 2 char with row number 2 characters. That way, no matter what, well, I shouldn't say no matter what, but most of the time I'm then going to get a 4-digit wire number. And I'm going to, again, copy this because I don't remember if I actually copied it. Okay, I'm going to do the same exact thing for wire. Now, these are two different things, but I like to make sure they match. So I'm just going to go down here and paste and okay. Now, if I go back in, I'll have a current formula, right? And it's got what I've got here, what I've entered here. I'm going to again say sheet number 2 characters and row number 2 characters. I like completeness. I like if it gives me a chance to enter a description or comment or something, whether it's programming, whether it's drawing, whatever, I like it. So and it helps you remember what you did later. I'm gonna hit OK. Right? I'm gonna hit OK. I'm gonna hit OK. I'm gonna hit OK or close. I'm gonna go to my process. I'm gonna renumber so I get brand new numbers using those new formulas. And oh look, 0401, right? 0401, 0402, 0403, right? Based on the row. Now, the reason we do two columns, notice this is a 15. It should, if all is well, once I draw a wire over here, and this time I can just number new, it's on row 15 because there is now, we'd have to get pretty deep into the weeds of how this title block was created, but basically this gray line creates the second column and a restarting of the row numbers. It's a thing that's defined in the title block. So we've got, that's the wire number scheme I prefer. That's the wire number scheme we're going to use. I mean, it's about that simple, or that I'm going to use. I mean, you can really set it up any way you like. This is just the one I like. So we look at this. We know this wire, whenever we see it in the panel, is on sheet 4, row number 2. Right? Simple cross reference. So I can delete all of that now. There is one issue with what I just did. So we've got an issue. I'm going to go back to schematic, and I'm actually going to insert an item this time, which is insert a symbol. So symbols are basically everything. Now, by default, SolidWorks Electrical has some. It does not have a ton. But if we look, we've got buttons, we've got switches. We should have some fuses. right? We got symbols. I'm just going to grab a fuse for now. The cool part is you can go out and I've done it and I will do it probably off video because it takes a minute, but you can download from, say, Allen Bradley, like a catalog with thousands of pre-built parts that they've already created and just straight up import them into your SolidWorks electrical library. You can do it with it. I know Weidmuller does that. Quite a few other manufacturers. That gives you way more selection on the parts that are available. Where it becomes more important than the symbols, because like a fuse is a fuse. But later, we're also going to attach this fuse symbol with a physical part number. That's where things get kind of interesting, where the selection, like the physical part number selection, is not great. Um, like if I canceled out of that, if I go to library and oh, manufacturer parts. So this is all of the manufacturer parts that come preloaded. And notice there are not a lot. Like these are all the fuses and fuse disconnectors that are available. Like, what if I want a 4 amp class CC fuse? There's one in here, right? I have to add it. And I'll show you how to add it. It's not a tough thing. But even better if we can just import, say, Cooper Busman's entire catalog, and then we have all the Busman fuses in here already, right? So it's a cool thing to do. I think it's a little beyond what I want to try to accomplish here, which is just get us started. Okay. So anyway, schematic, the drawback and the thing, and I'm going to take a second and actually do this live because I think it's that important. And actually, I'm going to drop. So usually, at least for the first go, I try to drop the part in there first. So insert a symbol. It remembers the last one. I had a fuse selected last time. It remembers that. So I can just drop it in. Makes it handy when you got to do more than one. All right, I'm going to drop it in. You can change. So the root is what it's going to call it as sort of a category. I like F. F is good for fuses. F is good for fuses. It's going to give it just an F1. And you can also make this a formula, this whole thing that is buried under the actual part definition. If we had a manufacturer part to tie it to, it would also automatically pull in the current and the size, all that good stuff, descriptions. For now, we're okay just calling it a fuse, right? It is F1. Okay. Then I usually go in and draw the wires because SolidWorks Electrical will automatically snap to and connect. So we'll snap to and connect, connect, connect. And again, I'm not dragging, I'm clicking once. And then when I'm done, right clicking, and that drops in my wire. And escape gets me out of the drawing of the wire thing. But now if I number my wires, process number new, that's a problem. That is a problem because electrically, those are not the same wire. Unless this is straight up a terminal block, which allows just current pass through, right? Because a fuse is removable. Or if this were a relay, because the relay's in the way. If there's something in the way, these are no longer electrically the same wire. We have a problem because they have the same wire number. That's not accurate. They're not the same, right? So the fix for that is a thing that I probably have to Google. I probably don't remember how to do it. Basically, what I want to do, anyway, is add. I want to add letters. Add letters to wire numbers. I want it to go through basically look at the order, like the wire order number that we had, and add a letter A, B, C. So 0401, 0401A, right? That's the way I like it. You can do it however you want. I do highly recommend, though, that you do something um, because we need to keep those separate, right? They're not electrically the same. They are different wires. And somewhere in here, did SolidWorks themselves give me the formula? It's a pretty simple formula. It's just one that I would never remember off the top of my head. Passing a symbol for each passing type, create custom wire numbers. Go Engineer is usually a pretty solid resource. I may also cut this section out because I don't know how long it's going to take me to find the actual formula that I use. It's pretty simple. I do remember that you have to you end up actually listing A through Z, and it goes through. Basically, the formula is written such that it goes through and selects. Maybe I could use that. Is it that the switch? That might be what I want right there. The switch. I'm going to try that. I don't know if that's correct. Maybe we don't need this. It looks like we do need that. I'm going to try that, the switch right here, because it looks to me like what this is doing is depending on what the value of, I don't know what LTYPT is, but depending on what the value is, it's going to select one of these labels, which is basically what I want to do, except instead of whatever LTP is, I can use order number, right? We've already done that, or I've already shown you that. So I'm going to try it. I mean, why not? Usually, I mean, I know in the past I've just Googled it, straight up copied and pasted, but why not? Let's give it a shot. We can always, at this stage, I mean, I've literally just started this. We can always modify. It's a little trickier later. Like if I was, 3 weeks in, it'd be a little different, but I can click right down here and start to modify. So let's try switch. Is switch a thing? Did not like, so functions I've also got. What do we got? Functions are actual, programming commands I can do. String Z, format a float. We've already done that. Switch. It just needed to be capitalized, it looks like. There we go. Switch ABC. So that's what it says right there. Switch. Um, and then I'm going to do the val. So caps matters. So if I go lowercase, it doesn't pick it up. Caps matters. Value. Close that parentheses before I forget. We just have to channel our inner programmer a little bit. Value, and now I want to pop back to variables and grab that equipotential order number. Not with the liters this time, but just that, just the straight up variable. And I don't need that plus sign that it put in there automatically. All right, so it's going to switch. It's going to grab the order number, and just quick, I'm just going to put in A and B. I just want to see if it works. And actually, I think zero is a number. Is zero a number? Well, let's see. Let's see what it does with this. Let's see what it does with this. You're getting this live. I have completely derailed like the entire purpose of let's renumber of the video B and undefined. So, I mean, why? Like why? Maybe, I mean, maybe I'm just way off base on what that order number means. Let's check and go back to the formula. So equipotential order number is just numbers. So A, B, file order number. So we know this part works, right? We're strictly in the switch now. Switch A, B. And if we go here, back to our little reference, switch looks like what we want. We just need to understand the value of what we're grabbing is kind of what I'm gathering. And I mean, it came up with, well, let's try it again. Let's double check it. It came up with A and B. Let's redraw, insert a symbol. Let's drop this back in here. Draw wires and number them. B, so it's starting with, I bet it starts at 0. That might be, so B is actually 1, A is 0. That might be possible. So let's look at it from that perspective. In which case, make sure I'm in the right wire. In which case, again, equipotential. So switch value, equipotential order number. I'm going to add just a blank. Quotation is just going to give us a blank. It's not going to do anything. And okay that, okay, and then renumber those wires and see what we get. Like, why not? Renumber. Okay. There we go. That's it. The first one's zero. Uh, the first one's zero. Now, I also don't like this end result. I want my first wire to be just 403. So how can I fix that? Again, we're pretty deep in the weeds of programmer thinking right now, which we should be anyway. I mean, we're doing control, so we should have a pretty good grasp of some of these programming concepts. But right, I know now I'm starting at zero, which makes A one. One is that first wire I drew. It starts at one. I need to start at zero so that I get nothing. I don't want a character there. I'm pretty sure then I can just parenthesis this guy and subtract a one. So now I'll start at zero. It should select a zero, which is just a blank character, and then go to A. I'm gonna try it. I got nothing to lose, right? Again, process, renumber. Okay, boom. So the first wire I draw on this row will be wired with or labeled with the page and the page and the line number. And any other wires on that row will get the same wire, but it'll get AB. If I do another schematic, insert a symbol, other symbol. Let's put a part in here. What do we want for a part? Motor? Do I have a simple motor? Guess we can put a field winding in here. Call it okay. Put a field winding in there and let's draw another wire. I should get a B. If I just process a number new, I should now get a B. So about that easy. That took just a second to remember. I am going to go in. I won't do them all because I mean, I've already diverted this video enough. I will not do them all. One, I want to make sure that these two formulas match again, like I said before. I just want to also add a few more letters. I don't need a ton. I don't honestly ever recall getting above, I mean, really above us like a C. Really on a line, you don't really get that many unique wires. If you think about it, you got to have space in your schematic to actually put the parts, which doesn't leave a lot of space for a ton of wires in the middle. You usually end up dropping down to more lines, which starts two new wire numbers. So I'm just going to add a couple, just for the sake of A B C D E F G. Let's let's stop at I. That's enough for now. But I'm also going to copy everything after that plus sign so that those two formulas match because we didn't add that switch. Right now they match. Okay. So that when I do either, it'll match. Okay. Right. So pretty simple. I mean, and I also, as part of that, just ran through dropping in both um, wires and parts. So there's another way we can do that. So how I usually start um, a brand new drawing, like this is a brand new blank machine. So we're back at the starting point. I just corrected a problem that I saw that I knew was coming, right, with the numbering. We're back at a brand new machine. I've created the two columns. Usually, again, like I said, I leave this as the power page. And let's say for this drawing, I'm going to draw multiple wires. That's an option that I have. I can also do it with, I actually don't usually want to do it with single wire or with DC, but with three phase. Let's say this machine has three phase coming in. Fair. I'm not going to use protection. This one doesn't have a neutral. I've got phase one, two, and three coming in. So usually what I will do at that point is I'll usually make sure my cursor's, by the way, lined up with this hexagon. So I start there. And I use the cursor a lot for spacing. So if I've sort of got this fit in the screen, I'll go a cursor width away, right? I see where the tip of my cursor is kind of on the hex. Click and move my mouse down to the bottom, and I'll just go like that, from midpoint here, midpoint here. That way I'm in the middle of the row on the top and the bottom. And that's sort of just how I have always done it. So we've got our three phase coming in. I want to insert a disconnect, right? We've got usually a main power disconnect on this three phase. Now, the way I showed you before, right? was dropping in a device, uh, drawing a wire, from the terminals, which is perfectly valid. Well, it helps if you click. You got to click twice, right? That's perfectly valid. This is the other way, right? So I drew the wires first. SolidWorks Electrical is smart enough to drop a component on top of those wires and snap it in the direction it needs to be, and break the wires accordingly so that they get labeled right. Something like this, if I insert a symbol, I want to switch because now I want a fuse disconnect and I want a 3-pole. Now, again, this is where we need to be careful. This is an IEC symbol. This is an ANSI symbol. I'm in ANSI. I want to use this. I can use either one in this drawing. But usually the dead giveaway is these are set up for vertical rungs, which is IEC standard, ISO standard. ANSI is horizontal, so that's kind of the giveaway. So I'm going to double click that guy, right? And as soon as I bring it over here and touch it to the wire, one of these wires, it flips. See, if I go here, it flips it too far out of the way. If I go here, it automatically flips it, sort of lines it up correctly. And then it's just a matter, I want some wire up here. So I'm going to put this, I don't know, somewhere down here. It's a guess, really. I just know I want some wire on the top that sort of indicates it's coming from the building, right? That's all it's really doing. So if I come down here and just click, I can also manually reorient. Um, Over here on the left, we've got orientation, and as I click through the dots, you can see, or there's a shortcut, the space bar. I'm just hitting space, and it rotates through all of those rotation options. But by default, if I just pick a wire, it's going to orient it to try to fit it on that wire. So drop it in there. Again, I like Fs for my numbers. I may go back at a later date and change this. I tend to like my component numbers to not be labeled sequentially. This will label things sequentially, F1, F2, F3. I'd like to label things still according to page and line number. So F405 kind of thing. But again, if I cancel out of this, that's a thing we can always change in our project configuration. In that case, it would be, now I got to think, not, is it in drawing style? No. I have to think where that is, the actual formula that's not just sequential. I do believe it's in configuration project. Yes. Yes. It is under mark, project configuration mark, and we can change formulas for how it names our drawings. Right now it's just naming them in order, which I'm fine with. That one I don't mind. Rows and columns, I'm fine with. I don't mind. Origin, destination, we'll get there. We'll get there, as well as cross references. Maybe not in this video, but we will get there. But all kinds of other stuff down here at the bottom. So components are the root, which is the F. The root is the letter we tell it to use. Motors were M, if you remember, but a few minutes ago when I dropped a motor in. And the order number. That simple. The first fuse, second fuse, whatever. I don't like that. I want lines. I'm going to do that now. Boom. Oh, look at this one has, what does this say? It says file order number plus row number plus root. I don't like that. I don't want it. So that would be like 411F. And then it says plus a letter. Oh, hey, look at that. I could have just shortened this. I'm going to copy this because this right here, this short version, without copying A through Z, this little cheater method is picking letters of the alphabet for us without printing them all. I'm going to copy that for a minute, then I'll go back in my wires and change my wires. Hey, look at that. I learned something live. I don't like that. I don't like that. We've got root, component order number on 2 characters. I don't like any of these. So I'm going to create a new one. And really what I want is let's get rid of that. I want, let's go to the variables. I want the root, component root plus. Now I want the file order number. I don't usually for components use a leading zero. So like I want F4, not F04. It's just me. Set these up how you want. This is really, really powerful to get these things set up exactly the way you want to see them. Um, in an automatic way. So once you do this once, every time you reuse it, it'll pop in there the way you want. I'm going to go ahead and paste this before I forget that I pasted it. What this is going to do, so if the component order number is one, it's going to, this is a true false, right? If it's true, if it's one, it's going to print our blank character. Otherwise, it's going to grab a character 63 plus a value. So this is ASCII. 63 is one position in ASCII or two positions in the ASCII table before the actual letters start, capital letters specifically. So basically, it's going to take the value of the component. So let's say component number two plus 63 is 65. It's going to take character 65, which in ASCII is NA, right? And you thought when I taught all the lectures and stuff on ASCII conversion that it would be completely useless. Well, here you go. Years later, in a YouTube video where I'm, babbling stream of consciousness style, there you go. Useful stuff. Never know when things are going to come back to bite you. Anyway, so I pasted that just so I didn't forget it. Then, so we got component root, so that'll be like our F. We've got our file order number, that would be the 4. Then I want the row number, but I want the row number with a leading 0. So row number, that one does not have a leading 0, but I can always add. Let's get rid of a plus sign. That's one too many. I can always add that string Z thing. And if you need a reference, it's up here because it's something we could do for the book. I don't know why it's not there by default for the row. Seems like it would be a thing I'd want to do with the row more than the book, but row order number, uh, 2 characters leading 0. Everybody should be closed now. That should be okay. And I'm going to copy this again because that's going to be my A through Z thing. I'm going to copy it over to the wires while we're diverted, right? So there's my component numbering. I'm going to do this actual same thing here while I'm in here for terminal strips. I want terminal strips the same way. Yeah, I take that back. Terminal strips I'm fine with, I think. Yeah. Yeah, I'm going to call it okay. Apply that. Okay, I am going to dive back into the wires quick. I know you guys are probably tired of seeing me play with wire formulas, but okay, enter. Wrong formula. Component. We can't use component. We got to use. You do have to, when you're copy and pasting, you do have to use variables that actually exist. That variable does not exist. Component order number does not exist when we're talking about a wire. These are the available variables. We need equipotential order number. And we need to do the same thing in the if statement. Okay. And we'll run into the same problem. I'm going to copy this whole thing. Click OK. We'll run into the same problem when I paste it here because equipotential is not a valid variable here. We need wire and wire. So here, wire order number, and make sure when it throws a default plus sign, we get rid of that. And here, wire order number. And that should be val, I do believe. And there's an extra plus there. Val, I don't know where did that disappear? I'm going to undo a bunch of stuff. Maybe not. All right. I do believe that should be a value wire order number. Something didn't paste right, it looks like, but enter that. Okay, close. We'll find out in a few minutes. Anyway, now if I schematic insert my symbol, it should remember the 3-pole fuse, drop it in here. Again, position, I mean, I don't care so much. I just want some wire on top. I know that. Now it's telling me root number, but those get overridden by our formula that we just entered. So the mark is F405. That's what it's about to label this thing. So if I hit OK, F405, that's what I want. All of that to achieve, all of that to achieve that end, right? So, I mean, that's just sort of the basics. I mean, dropping components in are about that simple. Dropping wires in are about as simple as I've shown. Uh, Most of the rest of this video so far has just been modifying, getting that label correct the way we like to see it, the way I like to see it. Now, the drawback is I'm going to have to reuse this stream of consciousness video like every time I go to do this particular talk with students in the future, because now in my database, all that's all set. I'd have to blow it all away. I don't want to do that. I just went through it. Anyway, so let's say, I mean, we've got three-phase power coming in, right? We've got a fuse. I'm going to shorten these wires. Well, let's not shorten them up yet. So on our power, usually on our power, I will also throw, say, the DC power supply. Now, again, there may be two or three power pages, right? I might have a 480 power. I might have a 120 power. I might have a 24-volt power. And then I might switch to the control pages, which are IO and things. It just depends on on specifically. I mean, I can add just by right clicking and create new schemes. Schemes again are where we want to live. Just a scheme. These other wiring line diagram, all this other stuff, they have their place, but we will primarily want to live in schemes. This that we're looking at is a scheme. Um, but let's say now I've got a three-phase. I don't even know if there's one in here on the default, but I want a three-phase DC power supply. So I'm going to come in here and I am going to, that would be under power supplies, get it together. Three-phase AC to DC power supply. Double click. I'm going to drop it in, right? It's going to be the only thing on this page. So again, telling me it's number one, but again, the formula is going to overwrite it. So it's going to be G. I don't like G. Like, what is G for a power supply? That's probably an ISO or an IEC standard power supply. I can type PS right there. Now the root overwrites into the formula. It's going to be power supply 408. I dig it, right? Now I need to connect that guy to the three-phase. So again, multiple wires. My three wires are still connected. I can click right here on the red one. I don't have to do anything fancy. Right here on the red one. Notice that it automatically connected the other colors. Now I just have to think about where they're going to go. Right click. Oops, not right click. Right click escapes. If I click, a regular click, and come down. I mean, that's okay. I'm not nuts about it. I prefer, like, for appearance's sake, for the red to connect first. But I mean, it's three-phase. It doesn't really matter in a power supply. In a motor, it would. Remember, motor direction matters. It'll run backwards, but it doesn't really matter for what we're doing here. So we've got that. We've got three-phase connected, right? This page is not done. This page is not done. I'm going to draw a wire, and now we need to get the DC out, right? I'm on a single wire. Let's call this the DC positive side, and I am intentionally going to splay it out this way. We'll get there in a second as to why I did that. And I'm going to switch now to my new common wire, DC common, and splay it out this way. Right. Now, as far as this sort of demo is concerned, this page is finished. This page is wrapped. I'm going to label my wires. Process, number new. They're all new. Okay. I'm perfectly okay with the default numbering scheme for AC power. The L1, L2, L3, -1, -2. I am perfectly okay with that. I leave that alone. What I do, though, is because these are connected, the little pink dot tells me these are connected. It won't necessarily always label these. And I like to see a label here just for clarity. So it didn't label those, right? But in the database, it did associate them with these numbers. So I can just select them, just drag and select. So SolidWorks Electrical this way does function like SolidWorks. If I drag and move my mouse from left to right, I get nothing, right? I would have to select the whole wire. But if I go from right to left, whoops, with a click and a drag, anything I touch, whether I select the whole thing or not, gets selected. So I can select those. I can right click and I'm going to show the wire marks just that fast because they're already associated with these numbers in the database. I could do it here. The vertical ones I don't care about so much. These I care about. I want it visible where they go, right? I also have I didn't change the formula. Notice this is still number one. I didn't change the formula for that common wire. I could go back and do that, but I'm not going to waste any more time. I am gonna show hide wire marks on the horizontal one and hide the vertical one, right? So there, now we got a horizontal. Okay. This one I'm going to leave alone because honestly, I don't care about wire number one. I really don't. So now let's say, I mean, these wires now I'm ready to go to, a DC, either a DC power drawing or directly to IO, to DC IO. So I'm going to switch over now to my control page and I'm going to draw the vertical runs of a ladder. So again, schematic, single wire. Remember, do not forget that the last thing you did is what's up. Now you can switch back to the DC, but the DC plus, but why would I do that? I need a minus anyway. I'll just do the minus first. The minus always goes on the left. The plus, let's grab one. Oh, that was the AC. The DC always goes on the right. And again, I leave a little more gap on the right side because later on there are cross references and things, text that we need to fit over here. So leave a little gap also on this side between the border and here and between, this label, these labels and this rung. Here, I use my cursor as a guess to sort of get the spacing correct, right? I use the plus sign of the cursor off of the hexagon to get that spacing, right? So now I got two wires. I am not going to label them because if I hop back to my power, this wire I want to connect directly to here with a cross reference. That is very common in this kind of drawing. I want the common wire coming out of the power supply into wire number one, which I hate, to connect via cross reference to the top here. Right? Piece of cake. SolidWorks Electrical makes cross references kind of stupid easy. So that is what origin destination arrows is for. I click that. I get two drawings, right? I can use, navigation up here, change drawing one, change drawing two, previous drawings, both, whatever. I can navigate through the drawings, but I'm going to work in here in this little pop-up. And let's see. I want to select first origin symbol because I want to check it. So let's not. I know what's coming up, but for the sake of education, let's not. I'm not going to change the symbol yet. The default I will show you. I'm going to do a single insertion. Usually always sucks as a phrase. I apologize for grammar, but usually always you want to do a single insertion. And it highlights an end of a wire. Like if I did this one, it would highlight that one. So it's easy. I don't even have to be that precise. It highlights, I click, it's red now. It wants to know where is that going? Right? That's going to be the start. Where is it going now? And notice now when I go on the bottom, it highlights this one. But if I come over here, it does not highlight the purple wire green. That's because they're two different wire styles. That's why two different wire styles can be important, can be helpful. I want two different wire styles for two different types of power. It helps a lot with the cross references. The color doesn't matter so much. I can make them all black. I actually have made them all black. I had a customer complain about too many colors on his prints. I did do them on all black for that one customer. But colors can help because it's a quick visual reference. I can't connect a blue to a purple. It will not let me. But I can connect it to a blue. And if I click, there's my cross reference. All right. I'm gonna connect the purple while I'm in this window and close. So I was going to change the symbol because I absolutely hate the default. I hate how it labels it. So I do like the arrow. I actually do like the arrow. This is telling me it's out. This wire is going to page 5, row 1. Simple, right? This one as well. If I go to the control page, right, it's telling me this is coming in and it's coming in from page 4, row 10. it exists. It's perfectly fine to use that format. Also, notice once I connected them, my wire number came in because electrically, this is wire 409. It started on page 4, right? We labeled it on page 4. That's where it started. So it automatically brings those labels in. It also brings in the one that I hate, right? Because as long as this is just plain cross-referenced, it is electrically the same wire. So better, and the reason I was going to talk, I'm going to delete these, and it will warn you that you're going to delete the connector as well. So if I go back to control, that's also deleted. The wire number does not automatically go away. If I renumbered the wires, it would go away, but it automatically doesn't go away. It automatically populates, does not automatically go away. I'm going to do an origin destination again. This time I am going to change. I can select the symbol here, my origin symbol. Here in the US, in ANSI, we prefer something like this. Actually, we prefer origin. We need an origin, first of all. We like file and row in an octagon. And I have had also customers complain that I used the arrows and not the octagon. They're used to here in the US seeing cross references done with this symbol. So I'm going to select it, but the process is exactly the same. I'm also going to change destination symbol. Use the destination arrow, file and row, select. So now when I do my single insert and select the blue wire again, can't select purple once you select blue. So there, there, there. Okay. Close that. This is closer. This is closer. I still hate it. I hate that this text hangs out here because this isn't normal in the ANSI standard. Just the stuff in the hexagon is normal, or the octagon. I also hate the octagon because this doesn't have a leading zero, right? That is beyond the scope of this particular video. That is when I get into modifying symbols or creating our new symbols. It's easy to do. Like for instance, I'm not going to do the whole thing, but if I right click, I can symbol open and I can change everything about that symbol. Like I can get rid of the space between the I go back to my actual schematic. There's a space here, this dead space, right? That is because in the symbol for that octagon, there's a space. It's inserting here at this gray circle that's attached to this gray arrow. That's the insert point, and there's a built-in space before the octagon starts. Um, the leading zero comes from the fact that we're using this variable. We're using this variable. We're not telling it to throw a leading zero on it. So we can change these things. These things are pretty easy to change. Um, it's just a little beyond the scope of this video. I don't, and that's by the way, I'll go back in there. Symbol open. That's the one instance where we would have to save. If I made changes, it doesn't, these are not saved in a database. These are actual DWGs, like AutoCAD format drawings. So if I close this, it's going to want me to save it. Don't forget that if you actually make changes. I didn't make changes. I don't need to save it. So I'll do another video on symbols and creating them and modifying them because I cannot express to you as I'm sitting here making this video how much I hate that gap and I hate these out here and I hate that there's no plus. This one's upside down. That one I do believe there's an option somewhere within here to allow the symbol to rotate its own text. And in fact, process, where are we? There should be an update. Was it update data? I'll have to play with it. I will have it prepped and ready to go. Prep prior to the next video, like I prep my videos. But as a starting point, I mean, that is about that gets you pretty well started. I think with SolidWorks Electrical, getting wires in and getting components in. Getting components, there's another level of complexity. Once the components are in, there is a thing like I showed earlier, library manufacturer parts. We can actually put full on manufacturer, and this is Schneider, whatever this capacitor is, Schneider Electric with that part number. We can attach that to a symbol So I could pull a power supply part number from Sola Power Supplies, attach a part number to this, and then populate a bill of materials automatically just off of my schematics, which is awesome, which is a thing we need to do. For now, I'm going to leave the video here because I do believe that's enough of a start as far as getting the wires in, getting components in. It is literally that simple. Um, so hopefully this was helpful. Hopefully you get some value out of this. All learning is entirely accidental, I assure you. But at least hopefully there was some minor entertainment value. So again, I'm Brad Pearson. It has been a pleasure. Thank you for watching and hope to see you in the next video.